All right, in this example, we're going to try to graph a polar equation r equals 4 sine 2 theta. In the last video, we talked about how we would do this, but in this example, we just want to get right to it and practice graphing it. So earlier I had explained that we usually do these based off of an r theta table, in which case you pick some thetas and then you find the r's that go with it, because the r is typically written as a function of theta. Now, one of the tips I'd given earlier was to remember to hit the major angles. You want to make sine be as big as it can be and as small as it can be, so that you get the extreme values of the sine and cosine values to make r stretch as far forwards and backwards as it's going to get, and you make sure you get the extremities of these polar graphs. So when I say major angles, I'm thinking of angles like 0, pi over 2, pi, 3 pi over 2, 2 pi, the big angles. If you want to do more angles, you're welcome to try 5 pi over 6 and 2 pi over 3, but that's not the primary ones we're concerned about. All right, now there is a little twist to this example though. See, sometimes when students hear me say make sure to hit the major angles, and to where we want to take sine of 0 and pi over 2 and pi and those sorts of things, they think that's automatically what we would make theta. Sometimes that's the case, but for this example, that's actually not the case. See, I want to be taking sine of pi and 2 pi and those major angles, but when you plug in a theta, remember that it's being doubled. So what I actually want is I want 2 theta being 0 and pi over 2 and pi and 3 pi over 2 and 2 pi, etc. That's actually what I want the 2 theta to be, right? So that when 2 theta are these angles, I'm taking sine of what I'm calling my major angles. But this is not what theta is. So how do we find the theta? Very simply, we just divide both sides by 2. So theta would be 0 pi over 4, pi over 2 divided by 2, and then pi divided by 2, and 3 pi over 4, and pi. And then now you look at these and you say, well, Devin, hang on, pi over 4, that's not one of your major angles. But remember, you're doubling it. And so in actuality, after you double it, you'll be taking sine of pi over 2, which is 1, right? That's one of the extreme values that sine has. So actually, we're doing pretty good here. So these are the actual angles that we're going to put in our chart here. Now, just a quick side note, what if the 2 wasn't here? Well, if you just had sine of theta, well, then you would put, 0 and pi over 2 and pi, and you put your regular angles. It's when you have a coefficient out here that you have to divide those major angles by that, whatever that coefficient is, a 2 or a 3 or what have you. Okay, so let's get rid of that. All right, so let's put these angles in here. We had 0, pi over 4, and then pi over 2, and then 3 pi over 4, and then a pi. And then we can do more if we need. We'll stop for now, but we can keep going if we need to. All right, let's find the r values that go with these thetas. If theta is 0, sine of 0 is 0. 0 times 4 is 0. Plug in a pi over 4. Pi over 4 times 2 is pi over 2. So I'm taking sine of a major angle, pi over 2, which is 1. 1 times 4 is 4. Plug in a pi over 2 times 2 makes pi. Sine of pi is 0. Plug in a 3 pi over 4 times 2 makes 3 pi over 2. Sine of that gives you -1. So we would get -4. And then plug in a pi, sine of 2 pi makes 0. So here's a few values. We can do more, but you can see because of the smart choices of theta that we've made, we're getting the extreme values for r. Sine can't be any larger than 1 or lower than -1, and I'm getting the numbers like 4 and -4, in my chart here. So everything's looking pretty good. Okay, so now how do we actually graph this? Well, this takes some practice. This is a developed skill, so I would encourage you to practice a lot of these examples. But the best analogy that I have to help you understand this is to think about having a little man right here. I know this is kind of juvenile, a little silly, but just go with me because it really helps. Having a little man at the origin, and he's going to face his body in the angle of theta. And then when he faces that direction, he's going to shoot his pellet gun R units in front of himself. So when he's facing 0, when he's facing this direction, the R is 0, so he's not going anywhere. And this point would actually be the origin. Okay, and then he's going to go from 0 to pi over 4. Sometimes I'll put these little dotted lines in the direction of these angles so I can just have a point of reference here. So as he's going from 0 to pi over 4 and he's fanning in a counterclockwise fashion, the R value is going to grow from 0 out to a pretty large R value of 4, which would be, let's just put it out here for example. But we don't go in a straight line. He increases to this R value as he turns. So I hope this is clear when I draw this picture here, but this picture would actually look like this. It would actually be arced, because as he's turning, the R value is increasing. All right, let's see here. Next, we're going from pi over 4 to pi over 2. So we're in this little window right here. And the R value is going to go from 4 back to 0. So it's going to retract from 4 back to 0 as we turn. Okay, so that one's done. All right, now we're at pi over 2, and we're going to go towards 3 pi over 4, which is this angle here. And now this is probably the weirdest one of all. You're going to start at an R value of 0 when we're facing pi over 2. And in this window here, eventually our R value will be -4. Now, hopefully we're familiar with negative R values. If you're facing one direction and your R value is negative, it's actually graphed behind you. And so that's how we handle negative R values. So imagine facing this direction with your body, with your chest, but the R value being -4 would actually put it back here, believe it or not. And so within this little window here, if you have negative R values, you'll actually be graphing this arc behind you that'll grow to -4. All right, let's see, what else do we have? Next up, from 3 pi over 4, which is this direction, and we're actually behind ourselves because of the negative R value, then the next point will be pi comma 0. So in which case we'll come back to the origin because of the R value of 0. And we've stopped because we don't have enough values in our table. Now, if you're at all hesitant as to what this graph will look like in the end, keep doing more points, not a problem with that. But once you practice a few of these, you'll start to realize the patterns that these guys have. For example, I feel fairly certain I know what the rest of this graph is going to look like. And once you get to that point, it's okay just to finish sketching it out. I feel fairly confident it's going to look something kind of like this. And then come up here and do the same thing in the second quadrant. And then come back home. We'll have this thing that looks like a flower. It's a very popular graph. These are called rose curves. And so it's a very, very popular shape that we would get. So anyway, that's how we graph a polar graph. You make a table, make sure you hit your major angles, and I'm not talking about the theta, I'm talking about what you're taking sine and cosine of. Find the corresponding R's, and think of it in terms of as you're turning, the R going from 0 out to a 4 or a 4 back to a 0 or something along those lines.